Hi there, welcome to this physics tutorial on light. We're going to talk today about the speed of light as well as the index of refraction. So we're going to solve the problem shown. It says approximately how long would it take a phone signal to travel from San Diego, California to Honolulu, Hawaii through the air? And then it asks how long would it take if that signal were to travel through water? So the first thing we need to identify is the equations that we're going to use. So we know that there's an equation, velocity is the speed of light, we represent that as c, over n, which is the index of refraction through a certain medium. Now, the index of refraction in air is 1.02, and the index of refraction in water is 1.33. And that's going to be important because they ask us both through air and through water. The other equation we're going to need is that velocity is distance over time. Specifically, they're asking us to calculate how long, which is time. So we're being asked to solve for distance over velocity. But before we can use that equation, we need to figure out what our velocity is both in air and in the water. So to start, I'm going to identify how far it's going to be from San Diego to Honolulu, Hawaii. And I just Googled that, and I found that the distance between those two cities is 2,612 miles. Now I need to convert that to meters because we need everything in standard units. And when I convert that, we know that there's 1 mile, 1,609 meters. So when I multiply that out, I get 4.20 times 10 to the 6th meters. So that's the total distance from San Diego to Honolulu. Now I need to figure out the velocity. So let's first do it in air. So in air, we use the speed of light, which c is always represented by 3 times 10 to the 8th meters per second. That's what c is equal to. And then the n, we need to do this for air. So we're going to use 1.02. And when I divide those two, I end up getting 2.94 times 10 to the 8th meters per second. And now I have enough information to plug in to my t equation. The distance we said was 4.20 times 10 to the 6th meters, and I divide by my velocity that I just calculated. And that's the speed that this phone signal will travel in the air. When I multiply that out, I get 0.0143 seconds. So pretty quick. Now in the water, we're going to do the same process, but I'm going to use a different index of refraction. c, or the speed of light, is still 3 times 10 to the 8th meters per second, but this time the index of refraction in water is 1.33. And when I divide that out, I get 2.26 times 10 to the 8th meters per second. And when I plug that into my t equation, I now have the same distance because the distance from San Diego to Honolulu hasn't changed at all. But I have a new velocity because in water, the speed is going to be a little different. And when I divide those two, I get 0.0186 seconds. So it takes a little bit longer to travel through the water than it does in the air. And that's how we solve that problem. So see if you can find some similar problems just like this to try and use these same concepts. Good luck!